So we're going to start talking about a case study that will provide information on how to program with WebFlux. And this example is a variant of something we talked about before in the context of WebMVC. Before, we had talked about this LockManager case study using synchronous communication with Spring WebMVC. Now we're going to talk about it with respect to Spring WebFlux. And what this is going to do is it's going to use WebFlux to send and receive get and post requests asynchronously to and from a microservice that provides a distributed semaphore, or what we call the LockManager. And you'll see how this works, and we'll talk about the various pieces in this example here shortly. This is also important because it'll help to foreshadow what you need to know for programming assignment 2C. So here's what things look like. This is in the EX1 project in my WebFlux folder in my Live Lessons GitHub repository. And as we'll see, the client's going to send these get and post requests asynchronously. And that means that things can run essentially in parallel on the client and server, especially with some of the examples we're going to look at. The client is going to use something called Lock API, which is a Spring HTTP interface client proxy. So this is generated by Spring's interface client mechanism, and we'll talk more about that as we get into it. But that basically provides the key methods that the lock exposes to be able to create, acquire, and release these locks as part of the semaphore. And what's nice about this is you don't actually have to write this code. This code is generated automatically by the Spring HTTP interface client feature. The server side, of course, has a controller, like always, and it has a service, like always. And this microservice, the LockManager microservice, will be able to acquire and release locks either individually or in bulk using completely asynchronous processing, which is very cool. The LockManager controller takes the get and post requests and it turns them into Java types, in this case reactive types or regular good old Java types, and then it forwards them to the LockManager service. You can see here that we have this LockManager controller providing the various features that we need, and then the LockManager service is going to actually do the real processing, and under the hood it's going to use an array blocking queue, reactive programming, and virtual threads in order to implement the distributed semaphore. And we'll see how that works. It's really cool. Let's talk briefly about how the project is structured. Nothing too particularly surprising about this. There's a couple of packages. We have the main portion, which is where all the server-side code resides, and we have the test portion, which is where the client code resides. The server has the microservice, which is the LockManager, and it's got the app or application entry point, the controller, and the service, and it uses reactive programming and reactive types, as we will see here shortly. The common folder contains various project-specific helper classes, most importantly the lock class, and we'll talk about that. There's also a LockManager that's there as well. And then utilities have a general purpose logger utility. And then we have some resources that are used to give the name and the port number for the microservice that we're using. On the test side of the world, we have a test driver that initiates calls to the LockManager microservice, and we'll see that this is written also using reactive programming. It's pretty cool and shows off a bunch of interesting features, as does the server side show off a bunch of interesting features of programming with reactive types. And then we've also got a client, which is going to be the part that has the lock API. This is the declarative API that allows us to have Spring generate the code to do the proxy, so we don't have to do it, which is awesome. And then we've got a client beans, which is just used to make an instance of the lock API. We've got another resources file here that we can use to enable and disable Spring logging, which turns out to be very useful because it's very verbose when you run it with the default setting. But it can be very useful if you're trying to debug your program and it's not working. So you can turn it on and off in the application's property file, which is nice because you don't have to go in and muck with the code. So let's talk about the pros and cons of this particular approach, especially relative to the earlier implementation that used Spring WebMVC to implement a LockManager versus using Spring WebFlux. So first of all, one of the things we'll see when we look at the implementation is we use virtual threads on the server to improve scalability. And in contrast, the Spring WebMVC version of this app used the servlet thread pool. So there was a fixed number of threads, and we didn't use virtual threads. We could have used virtual threads, actually, but we didn't. So here we're using virtual threads, which is kind of interesting. And the client and server are both fully reactive and asynchronous. In contrast, the Spring WebMVC version we saw was not reactive or synchronous. It used some other techniques, such as deferred requests, but it wasn't fully reactive and asynchronous. We also use the declarative Spring 6 and beyond HTTP interface proxies, which are super cool, and you'll have to know how to use that for assignment 2C, so make sure you pay particular attention to that. It's pretty neat, and I believe, for my money, much easier to program with than retrofit's proxy generation mechanism, which is a little bit more crufty. And of course, there's always some downsides. The array blocking queue implementation is incredibly clever, and especially when you see how it's used with reactive programming, it's mind-bogglingly cool. However, it's not the most optimal way of implementing a semaphore. There's lots of other ways that are better. We just did this for fun, to show off some cool programming features that you get out of the box with reactive programming. So that's the end of the overview.